Computers are amazing, right? But guess what's even more amazing? They understand only two numbers, 0 and 1. That's it. This system of zeros and ones is called binary code. Think of it as the secret language that makes computers tick. Just like we use letters and words, computers use binary to process information, store data, and run programs. It's the foundation of everything digital. Why do computers use binary? The answer lies in electronics. Computers are powered by electricity, which can be either on or off. Binary, with its two states, 0 and 1, perfectly represents these on-off states. Think of a light switch, it's either up, on, or down, off. Similarly, in a computer chip, tiny transistors act as switches, flipping between on, 1, and off, 0, to process information. This simple system of on and off states forms the basis of all computer operations. But how do we get from letters, numbers, and symbols to just zeros and ones? This transformation is fundamental to how computers operate and communicate. That's where character encoding schemes come in. These schemes are like translators that convert human-readable characters into a format that computers can understand. One of the most common is ACI, or the American Standard Code for Information Interchange. ACI has been around since the early days of computing and remains widely used today. ACI assigns a unique binary code to each letter, number, and symbol. This means that every character you type has a specific binary representation. For example, the letter A is represented as 0, 10000001, which is a sequence of 8 bits, while the number 5 is 00110101. Each of these binary codes is unique and allows the computer to distinguish between different characters. When you type something, your computer converts each character into its corresponding binary code, which is then stored and processed. This binary code is what the computer uses to perform operations, store data, and communicate with other devices. It's the fundamental language of computers, enabling them to function and interact with the world. Section 4. Binary on the Move Data Transmission. In this section, we will explore how data travels across networks, making our digital world possible. Binary is also how computers talk to each other over networks like the internet. This communication is the backbone of our modern digital infrastructure. Data is broken down into small packets, each containing binary code. These packets are like tiny envelopes carrying pieces of information. These packets travel across networks, navigating through various routers and switches, from one computer to another, hopping from node to node, ensuring the data reaches its intended destination, until they reach their destination. This journey happens in milliseconds, making real-time communication possible. Imagine sending a message to a friend. When you hit send, your message is instantly transformed into binary code. Your message is converted into binary, a series of ones and zeros that computers understand, sent as electrical or light signals, traveling through cables or wirelessly through the air, and then reassembled into readable text on your friend's device. This process is seamless and happens in the blink of an eye. Binary ensures that data can be transmitted reliably and accurately across vast distances. This reliability is crucial for everything from simple emails to complex financial transactions. Thanks to binary data transmission, our world is more connected than ever before, enabling instant communication and access to information from anywhere on the globe. Section 5. Binary Math. Adding with 1s and 0s. Math in binary might seem strange at first, but it follows simple rules. Let's look at addition. 0 plus 0 equals 0, 0 plus 1 equals 1, 1 plus 0 equals 1, and 1 plus 1 equals 10. That's a 0, carry over the 1, just like in decimal addition. Computers use binary addition for countless calculations, from simple arithmetic to complex simulations. It's all about manipulating those ones and zeros. Section 6. Binary's power, efficiency, and simplicity. Binary's beauty lies in its simplicity. With just two states, it's incredibly efficient for computers to process and store information. Binary circuits made up of transistors acting as switches can be incredibly small and fast. This efficiency has led to the exponential growth of computing power over the years. From smartphones to supercomputers, binary is the driving force behind the digital revolution. Section 7. Binary around us, fun facts. Did you know that binary code is the backbone of all modern technology? It's fascinating how these simple sequences of zeros and ones have revolutionized our world. Binary isn't just confined to computers, it's all around us. From the moment you wake up and check your smartphone, to the time you relax and watch a movie, binary code is at work. Barcodes. Those black and white stripes represent binary code that scanners read. Every product you purchase at a store is identified and tracked using this simple yet powerful system. CDs and DVDs. They store data as microscopic pits and lands that represent zeros and ones. When you play a CD or DVD, a laser reads these tiny pits and lands, converting them back into the music, movies, or data you enjoy. Digital images. Each pixel in a digital image is represented by a binary code that determines its color. This allows for the creation of stunning visuals and detailed photographs that we see on our screens every day. Binary is the hidden language of the digital world, quietly powering the technology we use every day. From the apps on your phone to the software on your computer, binary code is the unsung hero. It's the foundation of our digital world, enabling us to communicate, create, and innovate in ways unimaginable just a few decades ago. Think about how far we've come, from the first computers that filled entire rooms, to the powerful devices we carry in our pockets today. So next time you use a computer or smartphone, remember the power of those simple zeros and ones. They are the building blocks of our digital age, making possible everything from social media to online shopping, and even the very video you're watching right now.